I think we've got a great program assembled this year, as you can see on the screen, and we have a couple of really exciting topics to hear about this afternoon. Incidentally, all of our speakers are joining us from Australia, and it's really early in the morning there, so I want to express my appreciation for them losing a little bit of sleep in order to join us today. I also want to thank Angus Australia for sponsoring this session today. They're a gold level sponsor and one of our international partners for the meeting this year. And as you've heard throughout the program the last couple of days, the sponsors are really critical pieces to this program in bringing you such a high quality program and being able to offer the meeting to attendees for free. So a big thank you to all of our sponsors, and especially to Angus Australia specifically for being a gold level sponsor for this session. With that, thank you all again for attending, and I will introduce our first speaker. Okay, so our first speaker today is Dr. Matt Wolcott. Matt works with the Animal Genetic and Breeding Unit, often referred to as AGBU, since October of 2004. His goals are to develop and improve genetic evaluation technologies for beef cattle breeders, which is directly relevant to what he'll be sharing with us today. His key areas of research have included development of novel traits for female productivity in tropically adapted cattle, and development of male fertility traits both as direct descriptors of bull fertility and as genetic indicators for female reproduction. He's worked with development and implementation of a large reference population of Brahman seed stock that can contribute high quality male and female reproduction phenotypes to the breed plan evaluation. He's also done work in temperate breeds, most notably a collaborative project to improve understanding of cow productivity. With that, let's welcome Matt to hear about the application of novel reproductive traits to genetic evaluation in both tropical and temperate beef breeds.
Good afternoon. Thank you for joining in on this unusual version of a conference, and thanks also to the organisers of BIF for asking me to come and talk about some work we've been doing in Australia, over the last 20 years or so. I was asked to talk about new reproduction traits that we're including in our genetic evaluation, how we're working those into industry, and how people are taking advantage of those to accelerate genetic progress for these economically very important traits. So there are three main areas I'd like to cover over the course of this presentation. The first is looking at how these new reproduction traits were developed, and that's going back some time into the research undertaken as part of the beef CRC. Secondly, I'd like to look at how these traits have been implemented in industry, and that'll be a fairly brief summary of the Repronomics project, and then a closer look at work we're doing within a specific Brahman seed stock herd, bringing these hard to measure and quite expensive traits into industry. Finally, I'd like to talk about some more recent research in temperate breeds, Angus and Hereford specifically, that's examining the genetics of reproduction for those more southern adapted sorts of animals. So firstly, just a bit of a look at how these reproduction traits were developed. And I really see this as having the aim of creating opportunities for breeders to select to improve reproductive rates in tropical beef cattle. So as I kind of pointed out earlier, the Beef CRC was a multidisciplinary collaborative research project. It involved lots of scientists looking at lots of aspects of productivity in the beef industry. A key component of it was that it's industry supported, and all of the CRCs required that they have industry funding which was matched by the government to allow the research to happen. And in this case we had significant support from industry to focus on tropical genotypes, and it very quickly became clear that reproduction was a key aspect of what what we needed to look at. As I said, it was about a 14-year progeny test. As part of the first round of that enterprise, we looked at steer productivity, which included, carcass traits. And we were also looking at heifer reproduction traits in their half-sib sisters. In the second phase, we moved on to look at cow rebreeding and lifetime reproductive performance. So just a quick look at the design of the experiment. It didn't involve massive numbers of animals. We really had the philosophy that we wanted to record everything we possibly could on these animals, and that being the case, we were not able to do it on a massive scale. But over that period, we looked at the performance of around 1,000 Brahman females and about 1,100 tropical composites. Those were all bred in cooperator stud herds and then contributed to the CRC where they moved to research properties at weaning. The breeding was designed. There were about 50 Brahman size and 50 tropical composite size, and they were allocated to ensure genetic linkage across the herds of origin and the properties where those females ended up. So female reproduction was recorded intensively in these animals, and as we said, their half-sib brothers were finished in the feedlot to about a 540 kilo live weight specification. So just a bit on the management of the females involved in these projects. So as we just saw, they were located at 4 research stations around Northern Australia. Heifers were first mated as 2-year-olds, which is very much standard for the industry up there. A little less standard, we enforced a fairly tight 3-month mating period. There is plenty of enterprises that leave bulls out all year round up there, but in this instance, we wanted to, push them reproductively, and a shorter joining period allowed us to do that. They were managed under decidedly commercial conditions. Feeding only happened, to avoid any critical body condition situations arising, which certainly did happen over the years that CRC ran, but there was never intent that these animals be maintained in anything but commercial conditions. We also made sure we gave females the opportunity to express as much of their genetic differences for reproductive performance as we could, which meant that we retained all of the females in the experiment unless they failed to wean a calf in consecutive years. So I think this is a key part of this aspect of the presentation and is central to what we will look at going forward. This is just looking at the traits that we've developed to allow us to describe female reproduction. For female traits, they exploit ultrasound scanning to look at ovarian function. It's a process that's very similar to preg testing, but the technician has an ultrasound probe and are able to image the ovaries fairly carefully and identify whether an animal is cycling or not. This is just a comparison of, on the left, a prepubertal ovary showing a lot of small black follicles but no apparent corpus luteum, where on the right we see an ovary that is completely dominated by a single large CL. Once you get a bit of practice with it, they are structures that can be identified fairly easily, but doing so quickly and accurately takes a lot of practice and a lot of skill. And it's something we've been thinking about as we go forward with this, building a bit of capacity in the industry for people to provide this service. So the first trait that we defined was age at puberty, and it was based on serial ultrasound scans to observe estrus, which meant that scanning started in animals at around 200 kilos, which wasn't long after weaning for many of these cohorts. and carried through for each heifer until a corpus luteum was identified. And that meant for some animals having up to 15 scans, before they identified that the animals were cyclic. The next key trait was one that was measured in lactating females, and again used this ultrasound scanning to identify when a lactating female recommenced cycling after the birth of a first calf. It was calculated as days from bull-in, the start of natural mating, until that first CL was detected. And by the end of the CRC period, we had about 60 records on animals that stayed in the experiment for their entire lives, which meant we had more than 350,000 scans collected over that 12-year period or so. And this is the first of the results I'd like to share from this beef CRC research, and these relate to cow lifetime weaning rate, which is just the number of calves a cow weaned divided by the number of mating seasons that she was in the experiment. I think the key numbers to look at here are the average for Brahmins at 0.62 or 62%, and for tropical composites at just under 80%. And these low reproductive rates are really what motivated a lot of the work done in this project. We've also got the range in sire EBVs for the size of these females, and in Brahmins that went from -11% to +16%, which means there was a difference of 27% in the weaning rate between the best and the worst sires. Like a lot of reproduction traits, it's not especially heritable, around 0.1 for both genotypes. And that low heritability, combined with the extreme economic importance of these traits, is a lot of the reason that we were pursuing the traits we'll go on to have a look at in just a minute. In contrast, our age at puberty trait was extremely heritable in the animals evaluated for this study. In Brahmins, it was 60% heritable. In tropical composites, 50% heritable. There was also large genetic variation for the trait within those genotypes. And this plot's just a demonstration of that for the Brahmin females. So the horizontal axis there is age in days at which females displayed their first corpus luteum, were pubertal. And the y-axis is just the number of females that were pubertal at those ages. So this is a distribution of age at puberty in the Brahmin females. And we can see with mating at around 2 years of age, there's only about half of those females cycling as they go into their first mating season. Given that we only applied a 3-month mating period, beyond the end of those 3 months, there's still 13% of animals which failed to reach puberty. And that's going to have, a dramatic impact on the potential for high weaning rates to be recorded. Of those which did cycle, about 90% conceived and 72% weaned a calf, which gave us our overall weaning rate of about 60%. I think the key result here is with this high heritability and large genetic variation, there is huge opportunity to apply selection to improve age at puberty in Brahmin females. And that was certainly the case for tropical composites as well. For the lactation and estrus interval trait, we also saw high heritabilities. The composites had a heritability of 30%, the Brahmins 50%. Again, large variation within these genotypes, which means we've got lots of opportunity to identify genetically superior animals. I think when discussing these two traits, it's worth pointing out that age at puberty only directly influences the first mating outcome of females, where this lactation and estrus trait bites every time animals go through the breeding cycle. So as far as economic impact, lactation and estrus interval is probably the more important of the traits. So this is just an example of estimated breeding values for the Brahman sires that were involved in this study. And it's worth for this audience pointing out that the EBVs we publish in Australia are descriptors of the animals themselves and not the differences we expect to see in their progeny, which just means that EBVs are twice the value of an EPD. And what we saw was that for these Brahman sires, there was a range, even if we cut off the outlier at the bottom of the page, of better than 200 days between the top and bottom sires. This means that the best size progeny will have a lactation and estrus period 3 months shorter than those of the worst sires in this list. And it's worth pointing out, as we look down this list of beef CRC sires and their lactation and estrus EBVs, that the more negative the breeding value, the more favourable the reproductive outcomes. So we're wanting lower rather than higher EBVs. It's also true that with that level of variation, under average conditions, there will be sires whose progeny are essentially not going to cycle within a short 3-month mating period. And we certainly did observe that in those bulls. You know, we identified heifers that were the progeny of a couple of those particularly bad bulls for lactation and estrus, and they didn't cycle before they weaned their calves. The other thing that happened as part of this project was a fairly close look at opportunities to improve our understanding of the genetics of male reproduction. So as part of the third round of the CRC project, the male progeny of the cows we've just been talking about evaluating for age at puberty and lactation and estrus interval were retained as bulls. They were semen sampled at 12, 18 and 24 months of age. They had sperm morphology assessments done, which involved looking at 100 cells for each animal, identifying any non-viable cells and classifying those into different specific abnormalities. But the key number we'll look at here is percent normal sperm, which is just the proportion of viable cells within that sample. A key result for this trait is that variation in general, and certainly genetic variation and heritability, were very age dependent. This table is a demonstration of the additive variance and heritabilities for Brahman and tropical composite bulls for samples collected at 12, 18 and 24 months of age. The first thing to jump out from these results was that Brahmans produced almost no viable samples as yearlings, and it was only at 18 and 24 months of age that we got useful samples from them. But there's a big difference in the level of genetic variation between those two sampling periods. Almost 200 at 18 months of age and less than half of that at 24. And the heritability is correspondingly 0.3 at 18 for Brahmins, 0.2 at 24 months of age. For the tropical composites, interestingly, they showed the greatest variation and the greatest heritability for the trait at an earlier age, at 12 months old. And it's quite consistent with what we see in these sorts of animals running under commercial conditions in Northern Australia. Brahmins become sexually active a lot later than their composite counterparts, and certainly a lot later than British bred sort of cattle. One of the really important questions that we wanted to address in looking at male reproductive performance was what information it could give us about their female relatives. And these are genetic correlations of Brahman bull percent normal sperm with female age at puberty and lactation and estrus interval. So as we saw in the last slide, at 12 months of age, we're getting no information from these young Brahman bulls. But at 18 and 24 months, we're seeing consistently negative genetic correlations, which is favourable. That explains a relationship of higher percent normal sperm with lower age at puberty and lower lactation and estrus interval, which are both desirable. And those correlations are strong enough that we can exploit these measurements as indirect descriptors of female reproductive performance. Really pleasingly, it's a measure we can take in selection candidates. So we can take a semen sample from a young Brahman bull, do a morphology test on it, include those results in a genetic evaluation, and via these correlations get information about the reproductive performance of their female relatives, as opposed to having to mate those bulls, do a progeny test on them, get their female progeny, mate them, see how long it takes them to become pubertal and how long it then takes them to conceive when lactating. So it definitely shortens the time for data to come in on these key traits. So I think just to wrap up the CRC element of this, I think key results from this work was that we had developed some really accurate descriptors of female reproduction, and that those were, for a reproduction trait, very heritable. It means we had tools which would allow us to make rapid genetic progress for these economically important traits in tropical beef breeds. We also showed that male traits can be exploited as genetic indicators of these females' descriptors of reproduction, but there's no getting around the fact that these are difficult and expensive and expertise-intensive traits to record. There is a lot of inputs required to get this data, which in the era of genomics makes them prime candidates for recording in a reference population situation. And that's one of the things we'll look at now. So just a bit of where we went from the end of the CRC before we wrap that up. In our breed plan evaluation for tropical breeds now, we have results for age at puberty and lactation and estrus interval coming into the analysis. They're being recorded intensively in research herds, which are putting data into the evaluations for these breeds. Genomics is being applied to spread accuracy for these traits to related animals. And both of them are contributing to the trait which currently describes female reproduction, which is days to calving. So we don't have separate EBVs for age at puberty and lactation and estrus. They're just driving accuracy via correlations with days to calving for that trait. More recently, we've also introduced percent normal sperm EBVs for Brahmins, and coming soon for Santa Gertrudis. And again, it allows breeders to select to improve percent normal sperm directly, and at least as importantly, it serves as a correlated trait with female reproduction. So the next couple of areas I'd like to cover are how we're taking these complicated, expensive traits from research to industry. And the first of those is a very brief look at the Repronomics project. This is a large industry-funded project that's led by Dr. David Johnson, who I think some of you will be familiar with, and is really applying what we learned in the BIF CRC on a larger scale and under more commercial conditions. It's still focusing on those same traits, so we're intensively recording heifers for age at puberty. We're looking at lactating first calvers and recording lactation and estrus interval. Unfortunately, we're not getting any male reproduction from this particular project, but it's one of the features of the next project we'll look at. The males in this case are being steered and are going to sorter to give us some carcass information. The Repronomics project has expanded on the breeds that were involved in the CRC. So we've still got purebred Brahmins involved, but we've also included Santa Gertrudis and drought master animals, which weren't in the initial CRC research. There's also plans for crossbreds and their performance to be evaluated in the next phase of this project. And that's likely to start in the next 3 or 4 years. And key to this work is that as quickly as we can generate this information in this project, it's being included in the respective evaluations for these 3 breeds at the moment. So we're getting this data as quickly as we can, and it's driving EBV accuracy within the commercial evaluations for these breeds as quickly as can be done. The next aspect of getting this technology out into the industry we'll look at is some work we've done with a privately owned stud producer in Northern Australia. The property is called Kaiuroo. AGBU has had a interaction with them for 5 or 6 years now. The Kaiuroo enterprise is an aggregation of 5 neighbouring properties in the Fitzroy River Basin of central Queensland. The map on the right there just identifies the location of the property relative to Rockhampton on the coast, which is kind of the centre for tropical beef production in Australia. Combined, the properties make up 34,500 hectares, 600 of which are irrigated Leucaena. Leucaena is a leguminous shrubby crop. It produces high energy, high protein feed, but is difficult to manage. Stock-wise, there are 1,000 Brahman stud females run on the 5 properties, and about 5,000 commercial cows. Commercially, the herd is targeting an organic market. It's a market that has reasonably high costs of production and tight specifications around what they accept. They're targeting turn-off weights of about 480 kilograms, and there are some minimum requirements around growth rate to meet these market specifications. That was challenging for the business when it started, and AGBU was approached in 2014 to try to evaluate the genetics of the herd and make any suggestions that could help them improve compliance for that market. So following a review of the Kaiuroo breeding program, it was identified that, like a lot of breeders of tropical cattle, low reproduction rates were a key limiter of productivity and profitability for the herd. Because the herd had been so well evaluated, we were able to benchmark them against the Brahman breed pretty accurately and identify that they were below breed average for days to calving and scrotal circumference, and about breed average for our growth, fat, muscling, tenderness and temperament traits. The review concluded that a targeted breeding program could improve profitability for the herd. Intensive recording within the stud presented opportunities to increase rates of genetic gain for these key reproduction traits. and the production system and market that they were targeting warranted creation of a custom selection index. So in 2015 we implemented an ovarian scanning program measuring age at puberty in all the young heifers and lactation and estrus interval in lactating first calf females. And all of the bulls were also semen sampled for sperm morphology testing at 18 and 24 months of age. This was an expensive process, and we approached the industry funding body MLA to see if we could get some assistance with the costs of this exercise, because we could clearly demonstrate that the data that was coming from this recording was of clear benefit to the broader industry across the entire Brahman breed. Data was going into Brahman breed plan and was benefiting any animals that were related to those recorded in the Kaiuroo herd. Importantly, it was also the only source since the end of the BIF CRC of percent normal sperm data coming into the Brahman evaluation. Thankfully, we were successful in attracting that funding, and we got some support to help us with the cost of the recording program, as well as genotyping of all of the males and females that we were evaluating as part of the project. We were also careful to make sure that the project was well linked to the Repronomics project by exchange of genetic material. So the data coming from this can also be analysed as part of that project. So to date we've collected about 700 records of age at puberty in heifers, about half that in lactating first calf females to describe lactation and estrus interval. About 725 bulls have been evaluated for percent normal sperm, and all of these animals have been genotyped with a custom Bos Indicus 35K chip. So far we've evaluated the progeny of 70 bulls over the 3 years of the MLA project. That's been a total of 7,100, those sires have over 7,000 progeny represented in the broader Brahman evaluation, and 26 of them have progeny outside of the Kaiuroo herd, which totals almost 2,500 animals. As a result of the recording that's occurred just in the progeny of those 70 bulls within this project, we've seen an increase in the accuracy of percent normal sperm EBVs of about 30% across all 70 of those sires. Obviously that fluctuates from animal to animal, and we have to acknowledge that we were starting from a pretty low base for some of these bulls, but an average increase of 30% gives people much better opportunities to apply selection for the trait and do so accurately. Our female recording has resulted in increases in days to calving EBV accuracy in the order of 7 to 15%. This was already a herd that was recording the trait reasonably well, so we're just creating increased spread in the EBVs for animals related to those females recorded as part of this exercise. They're also getting a fair boost in female reproduction trait accuracies from the Repronomics project, given the links that we've established between those two projects. But the effort within this one herd has spread opportunity to apply accurate selection for reproduction traits to a lot of breeders around the Brahman breed. Finally, and fairly quickly, I'd like to just bring you right up to date with some work we're doing currently in temperate breeds. We've done all this work in the last 20 years looking at these traits in tropical breeds, and this is just playing a bit of catch up really in temperate breeds to help us understand the genetics of these traits in Southern Australia. So the objectives of this work was to apply the serial scanning methods that we developed in the beef CRC to look specifically at age at puberty in temperate beef heifers, and that was a group of Herefords and a group of Angus females from seed stock breeders. We wanted to quantify the variation in age at puberty in the current population, just see if there was any differences. We really were going into uncharted territory with this. We weren't sure what we would see, and certainly we do not face the same level of problem around reproduction in temperate breeds that we see in the tropicals. And once we've collected these records, finally to look at the genetics of these traits, whether there's genetic variation, whether it's heritable, and whether there are any genetic relationships with cow body composition. So the animals involved in this study were from 7 Angus herds and 3 Hereford herds. They were all herds that have a long history of submitting good quality data to breed plan. They were registered with their respective societies, and as an absolute minimum, we needed them to be contributing dates of birth and genotypes with pedigree recorded. All of them were doing that, and all of them were doing far better than that. The traits we were looking at is a binary trait, 1-0, whether animals were pubertal into mating or not. We also had age at puberty as defined for the BIF CRC, just the date at which we observed their first corpus luteum minus their date of birth. And for any animals that weren't cycling, we also created a penalised trait, which was the maximum age at puberty of an animal's contemporary group plus 21 days, one cycle, for any animals which failed to display a CL up to mating. And in this case, mating was synchronisation for AI. So all of these, we had to stop recording once these animals were synchronised. Obviously, synchronising estrus completely removes our opportunity to record it as a natural trait. While we were ovarian scanning, we were also recording information about female growth and body composition. So we're getting weights, measuring hip height, using ultrasound to measure fat depth, and giving the animals a body condition score. That's 1 being poor and 5 being in extremely good condition. It's worth pointing out that the technicians that we used for this work were extremely good, experienced ovarian scanners, but they were not accredited breed plan carcass scanners, and most of them hadn't had a lot of experience condition scoring. So I think the key result to come out of this, and it was one that we really were not expecting to see, was that only 52% of heifers were pubertal as they entered their first mating, as they came in for synchronisation for AI. So these results are just some averages and standard deviations for the Angus and Hereford animals that we scanned for this project. And we've got results for their age at puberty, the penalised age at puberty, with such a high proportion of animals not pubertal, this trait then becomes a really key trait. There's also averages for the proportion that became pubertal. We can see we got records on almost 3,000 Angus and almost 1,000 Herefords. And as we said, they're only about 52% pubertal going into mating. Age at puberty for those animals that were cycling was very close to a year old for both breeds, and with the penalty applied for those that didn't cycle, it got out to almost 400 days. The next thing that was interesting was that on average these females weren't in bad shape. We really can't blame condition on their failure to show any signs of estrus up to their first mating. This again is just some raw averages of their growth and body composition as at their first scan, so that's post-weaning, and their final scan into mating. Post-weaning, animals were just a little bit under 300 days old, a little bit younger for the Herefords, into mating around 400 days. Weights, they were around 300 kilos at their post-weaning scan, 300 and almost 70 for Herefords, 370 for Angus, 340 for Herefords. Hip heights were almost identical. Condition scores are a bit telling here, and both at 2.9 for Angus, 2.6 for Herefords, are describing animals that weren't in bad shape, although it's worth pointing out that there was variation in this. There were certainly animals within herds that were not in as good a condition as some others. Fat-wise, 5 mils of fat post-weaning for the Angus, going up to 7 into mating, and almost exactly the same result into mating for Herefords. So those results show that on both at the raw level, for both puberty and growth and body composition traits, Angus and Herefords showed almost no differences at all, which was pleasing, I must say. This was not set up as a breed comparison. It's inevitable that people look at these results that way. There's no capacity to pick differences based on the design of this experiment, but it was nice to see that they're pretty much the same. This is just a demonstration of the proportion of animals within each breed, that's red for Herefords, black for Angus, at each scan. On average, our Angus got 4 scans from post-weaning to mating, Herefords only got 3. But we can see that trend is very consistent across both breeds and describes a pretty consistent rate of animals becoming cyclic over that period. The big question in all this is, do we have opportunity based on these measurements to make useful selection decisions? And really pleasingly, age at puberty in both breeds was highly heritable for a reproduction trait. So if we just look within the animals that had a CL up to their first mating, the trait was almost 30% heritable, 0.26 for Herefords, 0.27 for Angus. The penalised trait, which becomes the go-to trait for most of our subsequent analyses, about 10% more heritable, 38% for Herefords, 37% for Brahmins. And even because it's so close to 50%, analysing the binary percent pubertal trait gives us opportunities to make genetic progress for the trait. 36% heritable in Herefords and 32% in Angus. Finally, one of the key questions we wanted to address in this early work in Bos taurus animals was whether there were genetic relationships between body condition, that's growth and body composition traits, prior to mating, and their performance as far as puberty went. And I think it was interesting to observe that there were not strong genetic relationships between either their weight, their height, how fat they were, or their overall condition score. And this table just presents the genetic correlations in the right-hand column between the penalised age at puberty trait and these 4 metrics of growth and body composition, weight, height, fatness, and condition score. We can see that all of them describe a relationship of higher growth and body composition with lower or younger age at puberty, but that none of them are especially strong. The strongest relationship was actually with condition score at -0.26. but it's not suggesting that there are causal links at the genetic level between these traits, and certainly, unfortunately, no real opportunity to exploit these much more easier descriptors of body condition as correlated traits with age at puberty. So I think the next steps in this work, we need to record the trait in naturally mated females. When I designed this project, it was, on the back of massive anecdotal evidence that these breeds do not have major problems with reproduction. Certainly conception, calving, weaning rates are pretty good for Angus and Hereford heifers. The fact that we only saw about half of them cycling into mating means that we're going to have to continue scanning beyond mating, that we can't synchronise for AI, and we have to observe variation as bulls are introduced to the herd and see what happens between then and the end of that mating period. To that end, there's a new project just in development that will mate 2,000 females of numerous breeds annually, and all of those will be evaluated, or the progeny of all of those as they come around will be evaluated for age at puberty and lactation and estrus interval. These are all females that are sourced from well-recorded herds, and we've got as many breeds as we could represented in that study. So there will be Angus, Herefords, Shorthorns, Wagyus, Charolais and Brahmins involved, and those Brahmins will give us linkage to the Repronomics project up north, which will really add to the value of this work. So just to summarise, I think over the course of the research that we've described in this presentation, we've been able to develop and prove some methods to accurately describe reproduction in both males and females for tropical breeds, and those traits have been implemented in the genetic evaluation for those breeds. We've developed a framework for reference populations, both in a research-based structure as well as in commercial seed stock herds, and that's been undertaken successfully. In temperate breeds, the research into these traits is at a much earlier stage, but our early results suggest that age at puberty definitely warrants further attention. The fact that we only had 50% of heifers pubertal into mating, I think, means that it's a trait that needs to be included in the genetic evaluation and at least monitored as selection pressure is applied in other aspects of productivity. Clearly, for those breeds, we also need to tackle lactation and estrus interval, and that will be the focus of future research in those breeds. Thank you for your attention, and I look forward to taking any questions that you may have.
All right, awesome. So I think we've got Matt on the line here. If
Good afternoon.
Great. So I see that we have several questions in the chat. I'd like to invite anyone else that has a question to please go ahead and post anything that you want to ask Matt. And I see in some of the answers, it looks like you wanted to address a few of them live. So I'll hand it over to you and you can go through the questions that you want to do.
Thanks, Megan. I think the big one, and we kind of got around to it as the talk went on, was if there's any association between these growth and body composition traits and what we're observing in genetic reproduction. And as much as we'd like it to be the case, those correlations aren't strong. Generally, certainly not good enough to allow us to rely on measures of weight and fatness and eye muscle area to give us useful information about reproduction. And the bottom line, and we've been saying it for a few years now, is that if we want to effectively include reproduction in our genetic evaluations, we're stuck with having to measure it. And these new traits, give us the opportunity to do that as accurately as we can.
Okay, scanning through here. Looks like we have one more new question. Have you done anything, or are you planning to do anything with activity meters to record age at puberty?
Yeah, absolutely. As luck would have it, while this scanning was going on in a subset of these Angus heifers, we had some collars on that included measurements of activity, and one of the first reactions to these results was that our scanning wasn't capturing the trait as well as it did in Brahmins. We thought it could just be missing it and be wrong, but we did have these activity meters which were identifying first estrus in young heifers, and pleasingly identifying almost exactly the same animals cycling at almost exactly the same time. So I think there's real opportunities to improve the ways we're recording the trait, and hopefully reduce some of that labour intensiveness. Although these remote sensing methods bring their own issues, but it certainly opens up possibilities.
Awesome. Well, I'm not seeing any other questions in the chat box. So with that, I'm going to thank you again, Matt, for joining us today. We can see through your window back there that it's still dark outside. So
and through my eyes.
Yeah. Very much appreciate you putting together all this really interesting information to share with us, and for taking the time to join us today. So thank you again.
Thank you, Megan.
Yeah, you bet. Okay, well, with that, I think we're going to go ahead and roll into our second talk. And our second talk today is going to be delivered by a pair of speakers. So I will introduce them both. So first, Christian Duff is the Strategic Projects Manager for Angus Australia. And his main role is overseeing Angus Australia's R&D initiatives, including the Angus Sire Benchmarking Program. He is also involved in the Pedigree Export Certification Service and the Australian Northern Development Program. Christian's also a part-time PhD candidate at the University of New England, focusing on research to further understand and improve genetics for meat quality in beef cattle. And Christian's partner today in discussing ImmuneDEX is Dr. Brad Hine. Brad is a research scientist with the Commonwealth Scientific and Industrial Research Organization, or CSIRO, in Australia. He has expertise in ruminant immunology and conducts research aimed at developing methodologies to assess immune competence phenotypes in beef cattle and developing alternatives to antibiotics to prevent and treat disease in food-producing animals. Brad has a particular interest in assessing resilience traits in livestock related to an animal's ability to cope with challenges in their production environment, and how such traits can influence the health, welfare, and productivity of livestock in a changing production environment. So without further ado, we're going to hear from Brad and Christian about measuring and selecting for immune competence in Angus cattle.
So good afternoon everyone, and thanks for joining in with the discussion today. My name's Brad Hine and I'm a scientist at CSIRO here in Australia, and later on in the talk you'll hear from my colleague Christian Duff, who's the Strategic Projects Manager here at Angus Australia. So we'd just like to thank the organising committee for the opportunity to talk to you today about our work on measuring immune competence in Angus cattle here in Australia. This has been a collaborative effort between CSIRO and Angus Australia, and you can see on the title slide there a long list of people who have made really important contributions to the work along the way, so we'd just like to acknowledge them as well. So in the presentation we'll step through what is immune competence and why is it important to the beef industry, how do we actually go about assessing immune competence phenotypes, what phenotypes are available and the analysis that has been undertaken to date. Christian will tell you a bit about what exactly ImmuneDEX is, and we'll finish up with some details of what the future holds. So it's common practice for commercial producers in Australia to buy sires from their preferred seed stock suppliers, and when those producers are making selection decisions on sires, they have access to a lot of estimated breeding value data on a multitude of traits that are related to carcass, growth, reproductive performance, etc., that can help them with their selection decisions. What we haven't had up until now has been information on traits that are related to health and fitness that will allow producers to place some selection. So good afternoon everyone, and thanks for joining in with the discussion today. My name's Brad Hine and I'm a scientist at CRC here in Australia, and later on in the talk you'll hear from my colleague Christian Duff, who's a bit about what exactly ImmuneDEX is. I have access to a lot of estimated breeding value data on a multitude of traits that are related to carcass, growth, reproductive performance, etc., that can help them with their selection decisions. What we haven't had up until now has been information on traits that are related to health and fitness that will allow producers to place some selection emphasis on these traits in their breeding objectives. So why are health traits important to consider? We know that consumers are increasingly aware and concerned about the use of antibiotics in food producing animals. Why are people concerned? And that is because of the perceived contribution that agriculture has to the ever increasing global problem of antimicrobial resistance. So as we move forward, there will be increasing scrutiny on the use of antibiotics in livestock as a consequence of these concerns. And certainly already we're seeing in many countries that the blanket use of antibiotics as a preventative for disease is largely stopped and will not be allowed to continue. So very important that we come up with strategies that can help with reducing our use of antibiotics. So it's very tempting to make the assumption when we think about health that the animals with the best immune system that are best able to resist disease are those animals that are the most productive animals. Those animals that are the most productive ones, you know, it's easy to make that assumption that they've got there by being resistant to disease, but there's mounting evidence out there now in many of our domesticated species that if we select hard for productivity, that we actually increase susceptibility to disease. So if there's one take-home message I'd like to give you today, that is that if you are selecting heavily for productivity, to not make the mistake that is actually selecting for disease resistance as well, because there's overwhelming evidence to suggest that is not the case. On one hand, we have the situation where if we're selecting for productivity alone, we're inadvertently increasing the susceptibility of animals to disease. While on the other hand, restrictions on our ability to use antibiotics in food producing animals is reducing our ability to treat disease. So in some ways we can see as these things merge together that there really is a perfect storm brewing. It's really important that we get ahead of the game and have strategies in place before we get to that point. So what can we do as a beef industry? Like many industry problems, it'll require a multifactorial approach to try and address these issues. So we can think about this in terms of genetics, environment and management. So from an environmental point of view, we can look at developing strategies to reduce the environmental pathogen load that animals are exposed to in our production systems. It's also important that we're looking at developing alternatives to antibiotics that can be used to treat disease in our animals. And what we'll be talking to you about today is a genetic strategy to improve disease resistance. So this is really a longer term goal to look at the ability of genetic strategies to identify those animals better able to cope with disease in their production environment. So yeah, my message is really that industry needs to be really proactive rather than reactive. And certainly here in Australia, we've been very lucky that the Australian Lot Feeders Association are investing heavily in trying to develop strategies to improve the health and welfare of animals in their system. So genetic strategies to improve disease resistance. The good news is that we know that immune responses in cattle are heritable, and therefore we do have potential to select individuals with a better ability to resist disease. And that's been demonstrated in the livestock industries for probably over the last 50 years, where we've been very successful in breeding for resistance to specific diseases in sheep, cattle, pigs, a whole multitude of different species. And what we'll be talking to you more about today, though, is about breeding for general disease resistance. Now, this was a concept first proposed by Bruce Wilkie and Bonnie Mallard at the University of Guelph back in the 80s, and the idea here is to breed animals that have the ability to have broad-based general disease resistance rather than concentrating on any specific disease. So the early work done by Bonnie and Bruce was really in pigs, and more recently Bonnie has taken that work into dairy cattle very successfully, and some of you may have heard about the Immunity Plus CMEX bulls that are highly disease resistant that have come out of that work. So I was fortunate to do a postdoc in Bonnie's lab, and that was where my interest in breeding for general disease resistance really started. So what are we talking about when we're saying breeding for general disease resistance? So if we just think broadly, the adaptive immune response targets the way that it handles different pathogen challenges, and the immune system's very good at working out how to eliminate pathogens. Generally, it's cell-mediated immunity that handles the intracellular pathogens like viruses and such, whereas antibody-mediated immunity is particularly effective at eliminating extracellular pathogens. So when we talk about breeding for general disease resistance, we're really looking to combine measures of cell-mediated and antibody-mediated immune responses in animals to try and identify those animals that are actually really good at doing both. So breeding for general disease resistance, as I just mentioned, different arms of the immune system are important for fighting different types of disease. And so there is a risk that if you select for resistance to one disease, that you can actually inadvertently increase susceptibility to other diseases in that population. And we've seen that with cattle selected for resistance to brucellosis. Although the cell-mediated immunity is particularly good in these animals, we know that inadvertently their antibody-mediated immunity is not quite as good. So breeding for general disease resistance, it's a really good strategy to combat complex diseases that are caused by multiple agents, and a really good example of that is bovine respiratory disease. These diseases are very hard to achieve 100% protection with vaccination, simply because of the multitude of agents and combinations of agents that lead to disease. Also, I think as in an ever-changing climate, animals are being exposed to new diseases. There's emerging diseases that animals are exposed to, and this type of approach is really appealing to help combat those emerging disease threats moving forward. So assessing immune competence in Australian Angus. So we've modified the methodology that was first proposed by Bonnie and Bruce back at the University of Guelph to tailor it to the Australian commercial Angus system. And a couple of modifications of note here are that we use a commercial vaccine to induce the responses we measure, and that was important for us so that we did not restrict the future sale of these animals for human consumption down the track following our testing. The other difference or modification that we've made is that we actually do our testing while the animals are under stress. We know in our production systems that we get spikes in disease incidence at those times when animals are experiencing stress, and a good example of that is feedlot induction, new environment, new diet being handled, and we get a spike in disease. So we specifically target the weaning period to do our testing, and we overlay our testing over that yard weaning period. And that allows us to test the ability of animals to mount an immune response when they're under some stress. So this is just a little quote which I think is a really pertinent one, and that is that the best immune system is not the strongest one, but rather the one that maximises fitness in light of constraints. And what that's about is, it's not necessarily the animals with the strongest immune systems that we're targeting. It's those animals that can mount a good response when they're challenged with a disease threat when they're under stress. So how do we go about assessing immune competence on farm? So as I mentioned, we overlay our testing on the weaning period. So we induce immune responses by vaccinating the animals on the day of weaning. We then allow the animals to respond to that vaccine, and we come back and measure immune responses. So we take a combination of measures of antibody responses. So we collect blood from animals and look at antibody responses in blood, and we also do a skin fold test, a little bit akin to the traditional tuberculosis tests that were undertaken to look at cell-mediated immunity. And then these measures are combined together to come up with what we call our ImmuneDEX value, and that's something Christian will run you through a little bit more later. So ImmuneDEX, it's really an index that is trying to predict the ability of animals to mount an immune response when they're under stress. We expect that it will reflect broad-based disease resistance, so our target here is not any one specific disease, but rather broad-based disease resistance. And we really hope that this will provide a tool for Australian Angus producers to start to place some selection emphasis on health traits for the first time. So I just thought I'd present some raw data here, looking at some of the measures we've collected that contribute to that ImmuneDEX value, really just to demonstrate how much variability exists within a given herd and a given contemporary group of animals. So the top graph is just weaning weight, which is a traditional measured trait here in Australia, and on the bottom on the left is our measures of cell-mediated immunity. On the right are measures of antibody-mediated immunity. So the bottom axis, the numbers refer to a herd and the letters refer to a year drop at that location, at that property. But what's really important here to see, I think, is that there is an enormous spread in responses within a given herd on a given farm within a given year. So that tells us that there's lots of potential to actually select animals that have an enhanced ability to mount immune responses. We're quite surprised by the amount of variation that actually exists in the population already. Once we had immune competence tested animals as part of the Angus sire benchmarking program, and Christian will talk a little bit more about those animals in a moment, we're able to follow these animals, a cohort of about 980 steers, through feedlot finishing at a commercial feedlot, to actually monitor our ability to actually predict health outcomes at the feedlot. So these animals were categorised as high, average or low immune competence animals. So to be a high animal, you have to be able to mount a good cell-mediated and antibody-mediated response, and vice versa. To be a low animal, that animal's not very good at mounting either a cell or antibody-mediated response, and the remaining animals fall into that average category. We were able to follow these animals through the feedlot finishing process, collect really detailed data on pull rates from pens, how animals were treated and what sort of drugs they were treated with, etc., the cost of those drugs, and cost of animals coming into the feedlot at the start, cost of feed per day. And from all of that, we were able to generate a cost related to health for these animals at the feedlot. So for high immune competence animals, the average cost was $3.53 per animal. For average, it was around $28, and for the low animals, it was around $103. So that's health-related costs per head of animals that entered the feedlot. So what was really interesting for us was that although only around 11% of animals we classified as low immune competence animals, they actually contributed to around 35% of the total health costs that were associated with that cohort of animals. So this was really encouraging. We will continue to work now to perform more validation studies on bigger cohorts of animals in commercial settings, and that's really where we're at. So I'll leave it there and I'll pass it over to Christian to take you through the second half of the talk. Thank you.
Thanks, Brad. Good afternoon, everyone. I'm going to take you through the second half of this presentation, which is about where we currently sit with immune competence at Angus Australia in regards to what data we've collected using the methodology Brad outlined for immune competence, and how we've analysed that data to produce some SIRE information and what the next steps are. So to start with, where we're at in regards to recording phenotypes for this particular trait, the immune competence traits, we've currently gathered and analysed immune competence phenotypes on over 3,000 Angus steers and heifers at weaning, and that's from our Angus SIRE benchmarking program, which is our large progeny test and reference population program we run at Angus Australia, which has been running for 10 years now. We've currently got, out of those particular phenotypes we've got recorded and analysed, we're recording them from certain cohorts. We sort of recorded some in the early days. We did a bit of work on those in cohorts 2 and 3, which is back in 2012 and 13. And then we have just increased our recording as well based on calves born in 2016 and 17 and going forward from there. So we've currently got 165 sires with progeny represented with these phenotypes as well, which we've used in the analysis. So we've used that information, and all these calves they've got other things other than immune competence recorded. They've got all the other performance traits from birth through to slaughter in the steers and birth through to first calving in the heifers. And we've also importantly got genotypes recorded on those as well for our genomics reference and analysis. So basically what we've done is we've created some research breeding values on these, which I'll take you through more now. And we actually released a list of sires with research breeding values for ImmuneDEX, and I'll explain that more in this presentation, and released that in May of last year. So it's a very new analysis, released for the first time in last year worldwide in the beef industry, which we're very excited about, but it's a first step. We've got a fair bit more work to do in this space as well. This is what the report looked like. So this is the Angus ImmuneDEX report, the research breeding values, and again I'll take you through this in more detail and let you know where you can access that information if you're interested as well. So in regards to those phenotypes I explained, we had antibody-mediated and cell-mediated immune competence phenotypes on those 3,000 Angus steers and heifers at weaning. We created some heritabilities on those, and that was done through our friends at CSIRO as well and their genomics team. And once we crunched the heritabilities of those, the pleasing thing was they're heritable. So first of all, we knew we can do something with them genetically if we want to make some selection decisions. So antibody mediated response was 0.23 heritability, and cell mediated was 0.28. So they're moderate heritabilities. They're similar to our weight traits, for example, our weaning and yearling weights in our Australian analysis. So we know if we want to select on these traits and make a change, we can. Importantly, we've also done some little bit of work on correlations. These are not pure genetic correlations, I should say. They're correlations between the breeding values for the immune competence traits and production traits. But in general, what we've found is that there is a weak negative correlation with some of the production traits, particularly the weight traits like yearling weight, carcass weight, eye muscle area. So it looks like there is a slight negative correlation, which sort of fits in with the other species around the world, that if you select purely for performance, then your immune competence could go the other way on a genetic level. We've also found there's a weak but favourable correlation with the temperament traits, so things like docility score, flight time particularly. As you'd expect, those animals that stress less probably have better immune systems phenotypically, but also on a genetic selection level. I should add they are currently weak correlations that we're seeing, so we need to do much more analysis in this space to see if those correlations change, but that's how they're looking at this stage. And that's shown in this correlation matrix, and it's a heat map. So basically anywhere there's a red bit on the map, that means there's a positive correlation towards one. The more green the bit on the map, the more negative the correlation is. As you can see there, when the traits line up with one another in the matrix, they've got a correlation of 1, as you'd expect. Importantly, when you look at, say, ImmuneDEX, and that's what those values are down on the right-hand side there, the correlation with the ImmuneDEX value we've created, you can see there that there is a slightly more negative correlation with some of our weight traits like carcass weight, final weight, yearling weight, etc. And obviously you can then see also how the different immune competence traits fits into ImmuneDEX. Both of them are quite positively correlated in the ImmuneDEX value, which I'll take you through more in a minute. So that's what we're seeing at this stage in regards to the traits. Luckily, we're not seeing really strong correlations, because obviously if we had very strong correlations with some of our production traits, that makes it a bit hard to select for these things at the same time, immune competence with our production traits. But there's correlations there, but they're weak, so that's a good thing in regards to selection. Particularly if we're trying to drive these things in the same direction. Highly productive animals genetically that also have strong immune systems genetically. If you want to know more about the correlations and the heritabilities and how they were calculated, and about the phenotyping as well, there's been a paper published in October last year in the Journal of Animal Science. So I've got that up on the screen there for you. I encourage you to go and have a look at that paper and find out more. It's all very well documented in that particular scientific paper. Now, in regards to the ImmuneDEX value, just to explain that in more detail, first of all, ImmuneDEX is purely based on genomic relationships, so we haven't used any pedigree in this analysis. We've used our genotypes coupled with our phenotypes for the particular traits, and that's the way it was calculated, again outlined in that paper I showed before. Selection indexes looks to optimally combine the antibody and cell-mediated components of ImmuneDEX. So what that allows us to do is select for those two things at the same time. As Brad pointed out in his presentation, it's important we look at both streams of those responses. So the ImmuneDEX value is set up to optimally look at pushing those two things in a favourable direction when we're selecting on those. And I'll show you a paper next which outlines that methodology a bit more. So the ImmuneDEX value, what it does is it provides an estimate of a genetic difference between animals for overall immune competence, which is a key component of resilience. And in regards to the ImmuneDEX, if you're looking to select animals that will give you lower disease resistance in the progeny and particularly a high proportion of progeny with stronger immune systems, then you'd be looking for a higher ImmuneDEX value. Now the ImmuneDEX value, I can't give you a traits like we do in birth weight, for example, in kilos or eye muscle area in square centimetres in Australia. It's basically just an index unit, so that's something we'll also be looking to the future. Can we put it in some sort of unit basis on health outcomes? But at this stage it's just a selection index unit, basic unit as such. This is the paper I referred to, which shows and explains the method we used for creating the ImmuneDEX value, and it was available at the AGBU conference and presented there last year, so it's a conference paper. Again, I encourage you to get on and have a read of that if you want to know more about how we came up with the ImmuneDEX selection index basis. And that explains that in good detail. So what are the research breeding values saying for our immune competence? This is a list, and this is actually, I think, the top 25 bulls that were released. As you can see there, we've got the IDs of the bulls, the top bull being Paringa Red Pilbara K146, which particular cohort he was entered in the SIRE benchmarking program, and his research breeding value for ImmuneDEX, you can see it's plus 70. The accuracy at 92%, and how many progeny they've had analysed in the analysis. So Paringa Red Pilbara's had 20 progeny that's been immune competence tested through the SIRE benchmarking program. When using this is some of the advice we give to breeders. Obviously it's a research breeding value to start with, so you've got to be a bit cautious. Obviously as more data gets added and we enhance the models and look at things at different angles, obviously these things can change. But for those breeders that are really interested in this space and want to get on the front foot early and do some selection, there's information there now to do it. The good thing is there's significant range across the bulls. For the ImmuneDEX values, they range from 0 to plus 70. So if people want to incorporate those in their breeding programs, they can. Obviously we do suggest a bit of caution at this stage because it's still early days, but the information's out there for people to start thinking about it, and that's the important part. How do we think about building in some welfare and health type traits into our breeding objectives, if that wants to be done both now and in the future. Obviously there's a limitation at this stage about using what bulls we have available. They're all from the Angus SIRE benchmarking program at the moment. There's about 165 bulls in the list at the moment, so that obviously limits the bulls available to select on. However, a lot of those bulls are recent bulls, current bulls, and we are looking at methods to update these ImmuneDEX values going forward. Just about the variation we see in the correlation side of things, this is just, again, just looking at a correlation between our ImmuneDEX values on the x-axis and those bulls' Angus breeding index, which is our overall selection index, dollar index with economic weightings in it, in the Angus breed in Australia. and each of those dots represent a sire that we've got those two values available for. And as you can see, it's a fairly shotgun approach. There's not a great relationship between those two things at the moment, which is a good thing in regards to selection. So again, if you wanted to select high ABI bulls, you can still find ImmuneDEX animals that are high in ImmuneDEX as well. So that's a good thing in regards to selection, but things could develop as we go forward as well. We need to keep an eye on there. So where to find the ImmuneDEX RBVs? They're on the Angus Australia website. So if you go to the research menu item, and then you can see there's an item there that comes up as ImmuneDEX. So you click on that and it'll bring up the ImmuneDEX report that anyone can print out and have a look at. We're also just developing a system where it's going to be available on our online search facility, along with a range of other research breeding values in a special location, which we'll promote to industry soon. So that's another thing under development, so people can access it not just in a PDF report, but also in their normal searching and sorting on the Angus database search facility. So what does the future hold for ImmuneDEX? Well, first of all, we're going to continue collecting our immune competence phenotypes as part of the Angus benchmarking program in collaboration with CSIRO. Basically to develop more research breeding values on more sires and obviously improve the accuracy of the breeding value as well. And our aim is to, in the next, by the end of next year, 2021, is to have over 5,000 Angus animals with genotypes and immune competence phenotypes collected. And we're on track to do that. In the shorter term, what we're looking to do is update the ImmuneDEX research breeding value sire list based on about another 1,000 phenotypes we've got from cohorts 8 and 9 of our Angus benchmarking program. So we'll look to update the report in the second half of this year with that information included, which is obviously a good step. The other thing that Brad's also mentioned that's happening in conjunction or in parallel with this is CSIRO and MLA have a project going where they're looking to further examine the benefits of selecting for immune competence in standard commercial feedlot environments. So particularly linking up, if you do select for this trait, high or low, what are the outcomes in feedlot environments in regards to disease that they see commonly in those particular environments. So that's obviously an important part of this process, to be able to link those things up to provide more information back on, if you do select on this research breeding value, which we know you can change genetically, what are going to be the outcomes in the progeny going onto feed, for example. Obviously another important part of this process then is to also develop a pipeline for regularly delivering research breeding values back to industry. So what we're looking to do at Angus Australia is set up a pipeline. So any animals that's genomically tested with a high density panel of 5,000 SNPs or more, we'll look to then also provide a research breeding value for ImmuneDEX back on all those animals that have been tested. Again, to broaden the number of animals we have available with this information based off their genomics and the reference population phenotypes, to let people start thinking about this particular trait in their own herds, in their own situations. And obviously with more animals with information available, that helps selection because you've got more animals to select from. So that's the next steps in the future for ImmuneDEX. So with that, that's the presentation finished, but we need to acknowledge there's a range of people involved in this. As we've explained, CSIRO and Angus Australia have been working for a long time on this project together, and it's working really well and will continue to do so. But we can't do this without co-funding, particularly from MLA and Alpha, who are our peak body representatives in Australia. They look after the research funding for beef, both in the grass-fed and feedlots environments. We obviously have to pay a lot of credence to our cooperator herds that allow us to go on farm and test their weaners. It's quite disruptive, so we obviously have to thank them for allowing us to do it and do the testing, the bleeding, the measuring on those cattle. Obviously there's a range of Angus Australia and CSIRO staff involved as well, including the GX team to do the crunching at CSIRO and also the technical staff on the ground. So we must acknowledge all those people who are involved, and we look forward to seeing where this trait's going to go in the future. That's for sure. So thanks for your time.
All right. Well. Oh. Well, thank you very much for that. Some really interesting information. And I see you both up on the screen here. So hello, I have no camera, but I'm waving. We'll maybe go through a few questions in the chat box, if that's okay.
Sure.
First is, what is the reliability of your validation reliability of genomic breeding values?
Yeah, it's a good question. It's probably a bit bigger than our research area, but look, going back to our talk, these breeding values and if we presented were based on genomic relationships. We didn't use pedigree in this particular analysis. So we're comfortable as Angus Australia that the genomic breeding values in this context will give us reliable breeding values, and I think there's plenty of information available that in other research areas that would indicate that. So but this area of research wasn't specifically looking at the overall reliability of genomic breeding values. We're comfortable that it's the way to go in this case, because the reason we went that way is because all animals' phenotypes also had a genotype. We didn't have a mix of animals that only had a pedigree or only had a genotype, so we went down the genomic breeding value path in this case. I'm not sure if I answered that, Megan, but I'll stick to that answer.
Sounds good. We'll have questions rolling in, and we've got some time, so I'll just start kind of feeding some more to you. Do you have feedback health data looking at the relationship between ImmuneDEX value and mortality or morbidity rate?
Yeah, so thanks, Megan. And yeah, we do have that data on around around 1,000 animals that we had immune competence phenotyped and followed through feedlot finishing. So what we saw there was the mortality rates, and these are health-related mortalities in those low immune competence animals, was around 6%. In the average immune competence animals, it was around 1.5%, and we actually didn't have any of our high immune competence animals that died from health-related illness. That was only in 1,000 animals, and we're certainly working now to validate those findings, and that's really key to moving this work forward, is for us to do more work in commercial feedlot settings to actually demonstrate that the relationship between our immune competence phenotypes and health outcomes at the feedlot. What was interesting in that initial study is that what we found is that the incidence, the high immune responder animals did get sick, but the encouraging thing was that they recovered from those health-related issues and returned back to the feedlot pen. So, but certainly we have a lot more work to do to validate these findings, and that's really where the work's at the moment, to do more work in that area.
Interesting. Thank you. So looks like our next question is, I understood you to say that more docile animals tend to have better immune systems. Do you think there might be a point of diminishing return on docility and survival, be it immune response and or calf vigor, and thus calf survival? Yeah,
good question. In relation to the genetic correlation, I guess we were just looking at the correlation between the breeding values at this point in time, but what it's indicating is there is a favourable relationship between docility and immune competence. So those animals that genetically are more docile through a range of measures, flight time or temperament scoring, will also have higher ImmuneDEX values or immune competence values. So that's what it's indicating this study, which sort of makes sense. Animals that are sort of better immune systems, less stress through their temperament, have a better ability genetically to also mount a resistance to diseases. In regards to selecting for those, I guess you have to be careful about single trait selecting and selecting too far anyway. I know in cattle in Australia, we've still got a long way to select. In all breeds, there's a big range in docility and temperament, so we don't have any concerns that selecting is going too far or could go too far in the definitely short to medium term to cause any survival issues. And I guess we need to make those links anyway on a research level. In regards to immune competence, it's something we have to think a bit more about because, and Brad might add to this, there could be issues if you select purely on immune competence and you had animals that had really strong immune systems, and where would that leave them with issues with more immune-related diseases, I guess you would say, in their systems. Do you want to add to that, Brad? Because I know you've got some thinking about it.
Yeah, so that's a question we often get is, can we push them too far down the immune competence track? And I guess we don't know at this stage, but certainly from the research we've done, we find that animals that are high responders, as an example, if you think about responses to a vaccination, those high immune responder animals tend to just reach a protection level quicker than the other animals. We don't tend to see that they continue to be hyperimmune, if you like. I think the immune system is very good at working out what it needs to do to achieve a level of protection. And so, of course, it's always a risk if we push very hard for the trait. But I think the evidence suggests that, you know, as long as we're using immune competence in some sort of selection index with other important key traits and just putting some selection emphasis on it, I think is the key here moving forward. We sort of don't expect producers to be, you know, placing all of their selection emphasis on immune competence, of course, just a portion of it. So yeah, I mean, I think for me, the key here is, rather than actually selecting animals, you know, targeting those animals particularly that are high immune competence animals, I think the key here is to actually remove the low immune competence animals out of the system. I know in the end you're actually just achieving the same thing, you're moving the average of the herd, but it's those low immune competence animals that we think cause us issues. They're the animals that don't respond to vaccination, and as you see from that, you know, preliminary data we have, they're the animals that seem to be causing the majority of our health costs in the system. So to us, if we can remove the low responders from the system, I think is probably the way to go.
Okay, looks like our next question has to do with testing the bulls and mentioning heritability in their progeny. I assume testing the bulls would be much more accurate for heritability in their progeny.
Yeah, to explain a bit further, at this stage what we've done is we've measured these phenotypes on steer and heifer progeny in our Angus side benchmarking program. So no bulls were tested themselves. We obviously produced a bull list with the breeding values in based on their progeny details. If we measured bulls, what the heritability would be, we definitely couldn't say it would be more accurate or higher heritability. We would know that. We'd have to test bulls and see. But what we've done here is we've measured animals that are in the commercial system, which I think is the important thing. So measuring animals that are going through the commercial system. So we can also link that to health outcomes in feedlots and things like that, in the steer progeny particularly. So that's why we've taken that approach, and I think we're getting that's a good approach to take for this particular trait. Measuring bulls, yes, there would be some options to do that through our seed stock and our members in Angus Australia, but we've taken this approach because it's a high value trait. It's a hard to measure trait. You need some skills like a sire to do it. Definitely not everyone can do this, so that's why we focus on our progeny test program and record those on steers and heifers rather than bull progeny.
All right, got a couple more questions. How applicable do you expect your results to be against U.S. Angus population?
Good question. That's a research question for the future, and I think we're lining things up pretty well to look at that through a couple of aspects. One is, you probably saw in our in this bull listing as the slide came up, we do have some direct US sires in our progeny test program. So we've got progeny measured in Australia on their direct progeny, GR, Profit, 10X, a few others. Plus a lot of the Australian bred bulls in the program also are by American sires. So we're going to have good genetic relationships to the American population. I'm confident about that. The second thing is, though, there is American Angus are doing some testing, I believe, through a program over there with Bonnie and a few others. Not using probably exactly the same methodology, but similar enough. And at the stage where there is enough phenotypes from the American population, and we're continuing to collect them. We'll look to do a joint research in that area as well, and that'll help us determine, do bulls re-rank from America to Australia for this particular trait. If we combine it together, which is good for this thing because it's hard to measure, so getting the phenotypes is not as quick as, say, birth weight or weaning weight in industry. So we combine that data set, makes sense. That's something we're discussing regularly with American Angus, that's for sure. So hopefully we can answer that question not too far down the track in a bit more detail.
Great. So it looks like someone has a follow-up question related to the mortality data that you presented, and they're interested in knowing what percentage of the mortality could be attributed to respiratory diseases.
Yeah, so in that data set, we do have details there. From memory, I'd have to go back and have a look, but about 20% of certainly the animals that were pulled from pens were for respiratory disease. Probably not as high as what you would normally expect. And that's partly because certainly the benchmarking calves, when they go through feedlot finishing, they're pre-vaccinated for BRD before they go to the feedlot. They probably don't, they're well prepared, they've been well handled, yard weaned, so they're ideal animals heading into the feedlot. So our work currently is on more commercial animals going into very standard feedlot environments in Australia, and that's certainly one of the questions we're very interested in, is whether we can see a reduction in BRD incidence in those high responder animals. So yes, there was some respiratory disease in those mortalities, but the mortalities were quite low in that study, and only 1,000 animals. So it's something that we certainly need to validate with bigger data sets moving forward.
Okay. I'm going to paraphrase the next question a little bit, and I hope I get it right. So would you speculate that the increased immune system or immune response or competence in docile cattle presents itself more due to working with people, or would you expect to see the same type of advantage if the animals were more in range conditions and undisturbed?
Yeah, that's a good question as well. I guess the work we're focusing on here at the moment in Australia is the relationship between animals under stress, particularly through the weaning period, in the relationship to feedlot outcomes in relation to their disease response, because that's obviously, there's issues there we need to address going forward, and Brad outlined a lot of those. And I'm assuming there's similar issues in America as well. In regards to disease outcomes in the field and in more range conditions, that's an area of research we need to do more work in, because there is some disease issues in Australia that are not related to the feedlot, they're related to field situations. Like a common issue that gets raised in Australia is pink eye in temperate cattle, in Taurus cattle, and regularly coming up from breeders is, which is a range condition, a field condition. If you select on high immune competence cattle, does that reduce incidence of pink eye? We don't have the answer there yet, but we're always thinking about how do we get the phenotypes to prove that up. And that could be the case for any disease, and that's the beauty of this trait, because it's looking at broad-based disease resistance, so it should hopefully help address a few diseases along the way, not necessarily just BRD where the focus is at the moment. Brad?
Yeah, so yeah, certainly we've concentrated on feedlot, looking at disease incidence at the feedlot this stage, but obviously looking at animals on pastures, definitely important for us as well. I can tell you a little bit about, we have done a lot of immune competence work in sheep as well, and definitely in pasture-based systems there, we've seen some real benefits for selection for immune competence. So we see favourable genetic correlations with diseases in the field. This is with sheep, of course, with things like fly strike, internal parasite resistance, and general health, through their productive life. So we're hoping that will translate into beef cattle as well. But at this stage, we've certainly concentrated on the feedlot side of the equation. But as Christian mentioned, as we're aiming for sort of general disease resistance, that'll translate into pasture-based systems as well. But that's yet for us to determine.
I think we have one final question in the Q&A box here, and that is, what is the genetic correlation between the antibody and cell-mediated immunocompetencies?
So yeah, they're favourably genetically correlated, but that correlation's quite weak. And that was a little surprising to us. The work that's been done in dairy cattle to date would suggest that they're actually negatively genetically correlated in dairy cattle. Certainly our work in Angus shows they're favourably genetically correlated, but that's not strong. So you may ask, well, why don't we just look at one parameter and not the other? But I think it's really risky to do that, in that if we think from a biological perspective, we're really trying to identify those animals that can mount a strong antibody and cell-mediated response. So we're very hesitant to start to just look at one particular arm of that immune system. That's what the whole immune competence story is really around. It's trying to get identify those animals with a really robust immune system that can handle a variety of disease challenges. So it's good news that they're favourably correlated. Will certainly help us along the way, but we still think it's really important that we concentrate on measuring both those traits, and we're certainly not planning to stop at just looking at these traits. We are doing research with a lot of other parameters, and with the potential to bring other measures in, things that we can measure easily on animals that can help improve our ability to predict health outcomes with the ImmuneDEX values are something we continue to working on. So it is a work in progress, and we'll continue to look at other measures along the way that could be incorporated into that index potentially in the future.
It's also worthwhile referring again to the paper in the Journal of Science about this. So if you want more specific genetic correlation values and heritabilities and things that we've provided today, then go to that paper, and that outlines all that in a lot more detail that we can provide you today, of course.
All right, great. Well, I think we've addressed all the questions in the chat and the Q&A. So I would just like to thank you guys again for putting together such interesting information to share with us today, and for taking the time to join us.
The state of Iowa and Iowa State University are proud to host the 2021 Beef Improvement Federation Annual Research Symposium and Convention. The convention will be located in downtown Des Moines with easy access to the airport, hotels, and local restaurants. Iowa State University is just north with its research and teaching farms. Join us in Iowa and experience how Iowa provides the beef industry with innovation to application.